No, why is that not automatically reconnected? Absolutely ridiculous. I can't even do save. What kind of ridiculousness is this? I can't save it. Why? I have these two and I don't know what it does when I start it. But it does apparently not load these things. Save it again to the same file. Yes. Config Pavue controlled Qt. Apparently it's not what I thought it is. Officially you should use pipe plumber or something like that. Wire plumber. Yeah. I'm going to assume that update skill only is always false. Hey, post. Clement. Yeah. False, false. So that means update skill only is false. So I should call add. Like that. And why do I get an error here, not here? Oh, I do. Shit, this is skill update. Hè? Hè? Disconnected is only returned from update, scale update. Which is called in the add function of approximation. At the end, yeah. So if we return disconnected, then we got 1 we got here, 2, it was not a replacement. And the number of relative samples is equal to 2. Which means that this was called. No, that's not what it means. Could be either one. The history is add, why add? Oh, because of this. Approximation pointer is set to the current approximation. Again, n is reset. So yeah, then we have to pass false. Right. I need to write this on update scale. I have the feeling this is not good. What does update scale do? Well, calls update on the problem scale. Scale update. Now this is to find the minimum. To find the minimum of a function. To be honest, I can't wrap my head around it at all anymore. Yes, I wrote this, but it's just code now. I don't see it anymore. Which is normally okay if it just works. It just works, then yeah, you don't have to look at it anymore. But in this case, I wanted to change something, and I don't know. I don't know if we can make this change, because I don't understand what this is doing. My idea, what I did was I split up this function into two functions, namely this function and a new function, with as effect that I am no longer updating this array in the case that I call this one. So previously I would call this function, which then updated relevant samples, but would not recalculate an approximation, but would still call update the scale. Passing, well, the relevant samples that were just updated, aka the new sample and the previous sample, the last two samples. And now I thought, well, if I don't want to update the array with the samples, because I am not updating the cubic approximation. So I'm just going to call a different function. I'm just passing the last sample and the new sample to that directly. However, if I do that a few times on a row, then I have a problem, because I think I have a problem anyway. Well, I'm no longer updating this array, and here I'm using that array. So I don't think that I would pass the same values to the update scale with this change. That is, I have to still write a code that passes those samples. And well, I had a feeling I can just pass only the new one. But since I'm not storing it anymore, then what will happen if I call it a few times on a row? Then it's definitely something changed. Probably it will work, but I'm not sure at all. Not at all. Not at all. I'm going to guess that it works. Like, yeah, continue coding this. And hopefully run into a problem very soon, so I still remember what I did. If there is a problem. So I want to write this, but I don't want to pass relative samples because I did not update it. I think I just have to pass another update, just takes this, so it takes an array of sample pointers. So let's make one here. And then I'm going to pass that. And I was not updating parabola, so I can just still use that. And already had two relative samples. Why would that even matter? If I can't do current index, I think I don't want to change that, but I have to store it somewhere. Let me think. I can just fill this thing with a pointer to current. And then blah blah blah, which means that current index is then 0. And then this one I want to pass a pointer to the actual array. This one at the actual, well, the last current one then. Current index. So the last one that the last sample that was stored in this array is being passed, and the one that is being passed now. But since this one is not stored in the array, then this never changes. So let's say I pass current is that the sample that's being passed is 1 and then 2 and then 3 and then 4. Then previously I would call this with let's say I call it with 2, and then the previous one was 1. So it would do 2 and 1, and then next one would be 3 and 2, and then 4 and 3. But now it's going to do 2 and 1, and then if I call it again, it's going to do 3 and 1, and then 4 and 1. So that's the difference. But I hope it will work. And the already had two relative samples. I can define it. But and why or how is that even used in the case that I only want to update? I mean, I don't know. Update. This one. That is this one. It's called saw more than two relevant samples. Oh, in total, yeah. Oh, just useful an assert. Does it really matter? I think it must be true because I think has sample must be true. So this is not true. Therefore this must be true. Oh yeah, absolutely. I'm just no, not even going to check it. Just true is good. But that means that number of relative samples must be equal to 2 already. So we'll test that. So this is nonsense. So yeah, this approximation belongs to a known extreme, and of course we can only determine that anything is an extreme when I have at least 2 samples. Otherwise I can't even have a parabola as approximation, and I would just have a straight line and not an extreme, not a minimum. Well, that doesn't have a minimum or maximum. I mean, also here, dude. In fact, it's so related that I'll just do it like that. Yo. Poo-poo. Okay. Let's see if this compiles. Well, it's pause. Let's see, double braces thing again. Cannot initialize an array element of type const gradient descent sample pointer. Dude, gradient descent sample const pointer with an R value of value type pointer. Oh, the double pointer. Oh, it is already. That's it. Yeah, okay. Blah. It's already a pointer on this. Well, in that case, let's run some tests. I think I need a gradient descent. Let's see. Yeah. I don't know, man. I think I need a different function. Do. Well, I can run it. It's all nonsense. Then hopefully it's the last one. Yeah, that's what I wanted to look at, I think. So that scale looks good, but okay, that's just the initialization scale. And yeah, that looks good. But don't think anything changed really. Well, what is this scale though? I think it's a gamma based thing or not. Jump to vertex. It's probably okay. So now we are having to do, I think, with the scale of an already stored extreme. So this is an extreme. Let's see, we see that it is telling me that it is an extreme. No, minimum reached. Handle local extreme. So we have it registered as an extreme. Its minimum is set to. And then we call update approximation update scale instead of approximation add. So this should still be the same parabola as the previous. It was 15 plus 3.2x plus 0.2. The same thing. So the vertex coordinate is of course the same. It's called new, but it just didn't change. The following relevant samples are passed to, it's hard to check because I'm printing pointers here. Well, I can see what this is. Minus 15. Well, that's the 5 here. I guess the new one, the new one is 5, and then the last one was obviously 4. And the 4 is the vertex itself, which is at minus 7.5. And it is minus 15 something. So we have now minus 15 something is the new one, which I stored at 0. And then the previous one was in the vertex, which is minus 7.75. And now for the first time you get away from vertex. So the new one is, previously you were jumping closer and closer and closer to the vertex. So every time it said that it was going towards the vertex. So you can find that back. Yeah, towards vertex. And now the first time you get away from vertex. Because, well, this is the parabola, and now the new sample is further away. But we found 5 by adding the scale to begin with. And the scale was on the other side, like here, so the same distance. That was the scale. And as a result, the scale doesn't change, of course, even though this 5 fits the parabola perfectly. But it's at the same distance. So the scale is the distance from the vertex to a point, a sample that doesn't deviate a lot from the parabola fit. Now 5 is exactly on it, and anything will be on it because this whole thing is just a perfect parabola on this side. But the scale didn't change because it's just, yeah, the same distance from the vertex to on the other side. Actually, it did change. It did not change in value, but the current scale was plus 7.5, and now it went to minus 7.5 because we are at the other side. Now we jump from minus 15 to minus 22.8, which is returned, because we don't have anything else to do. We are in a minimum, we want to go to a maximum. So we have this minimum and we want to go to the left. we are looking for a maximum, but we only have this parabola fit. So there is no maximum here. You can't jump. So you just keep going. So what I do is add scale again. So you end up somewhere here, right? Minus 22, yep. And since that new point is then also exactly on the parabola, the scale should increase. So let's dip space here. And indeed the scale did increase, as you can see. So yeah, that works. But if it works in every bloody case. Now, the thing that really changed is that I'm still having the old minus 7.5 here in. See, so the 0.5 previously, the 0.5 is minus 15 something would be stored here, and we have the minus 22.8 as well as the minus 15. But I'm no longer updating the array, so we always have the last point that was actually stored, which is then the vertex. The vertex is one of them, and then the other one is the new one. So as long as we keep moving away, that would be okay, I guess. I don't see a good reason. I don't see any reason actually to go backwards. But say we would go backwards, then the new scale based on those two would be smaller. But yeah, well, I guess it wouldn't care much because it wouldn't decrease the scale. I'm not sure though. Hello. So yeah, I don't know. Next one is too much energy, so the scale is not updated. It's rejected, I guess. Let's see, returning minus that. Entering, rejected. Well, rejected should mean that it doesn't do anything with it, including updating scales. Now we jump back to the best minimum and we go in the opposite direction. So now next we go to the best minimum and then the opposite direction. And it jumps the scale, and the scale is still set to 6. So now this distance jumps again and we get somewhere here. Apparently 7 something, all the way here. All the way here. Just 7 something, yep. Now that is deviating from the parabola. So you can at least see that happening. It's not calling scale update at all. It's calling add again. We switch back to a new approximation object. It's just the first sample. And that would be the second sample, and now we have a scale. That scale looks very big. I'm having a scale and they don't have a parabola. At least I do have a parabola on this one. Why is the scale much larger than this parabola is? Yeah, what? What happened? 22 is out of the window. Okay. History add. Entering, kinetic energy. Entering. These are just drawing events, so I ignore them. Update approximation of entering that. Entering approximation add. parabola fit through 7 and 22. Oh, I'm getting it. Yeah. No, it is okay. Yeah, of course it is okay. I was confused. I saw this scale being drawn here, but it's always halfway. So actually, it's 22 is well, somewhere here, and then you go up, and that cuts this parabola up there, and then that's the scale. So the scale is from the vertex of this parabola to where that cuts. So this just runs till 22, because 22 lays exactly on this parabola. So that is correct. Oh, no reason to believe that I broke anything. But yeah, then again, dubious. So then I was thinking, I can do my cubic fit as a member function of approximation, because I have the cubic already there. Which means I don't even need samples. Maybe I shouldn't even do the approximation, actually. Yeah, so the approximation object stores two samples in an array and fits a cubic through it. I mean, that's exactly what I wanted to do. Given two samples, fit a cubic through it. So having that already, you would just think that if I would actually write this function, then I would have code duplication. And not a little bit, aka this function cannot exist, should not exist. And therefore I'm going to make it a member function of approximation, in which case I don't need to pass these samples because you already have them, but I still need to pass these. And all the previous work then was done. The changes that I made to approximation were such that now it has an awareness of which of the two samples is left and which is right, aka that. So I can actually use it with this comment basically. So this does not fit a cubic polynomial anymore, but So we can revert to SL and RL here. Yeah, nonsense. I can switch between those things anyway. So I want to add that to this. What else added here? Put it under update scale. I should probably move these down altogether. If we want this function. Yeah, that's not doing much yet. And then I want to have all this comment not in the header. That's a bit too much. Let me just put that here then, I suppose. it work again? The pointer to assemble and current is replacement. No, it should be false. Nah, bloody pointer for some reason. So I add two samples and I just call the member function. Yeah, result is 0. Yeah, that's what we return. Okay, so seems that that works. I think I'm going to commit this. There's one thing I wanted to change actually. I don't want to send an event at all. If the cubic approximation is not valid. So where does that happen? Here. Can just yeah, don't have a specific test thread, so I'll just call this. Check that it is true. Yeah. Officially, I have to look at the div. But I must say that I'm thinking like, oh, it's all green, so that must be good. And then finally we actually get to implement this. So I already have the cubic. Going to add an assert anyway, I think. The out entering and debug output. Well, these are also input, so I might as well print them. And then I'm asserting that we have at least 2 samples, otherwise the cubic wouldn't even be valid. And then pretty sure I have to begin with making a beginning and of calculating the minimum and maximum, which I already did in another program, namely a clamp test, clamp check. The clamp check is doing exactly what I wanted to do already, namely I have 2 samples here, which I can change. And then you see the cubic being fitted through it, and the minimum and the maximum being calculated. And 1. So sometimes there's nothing and sometimes there's two. There's never just one. Well, actually there is one, of course, when it is like exactly, yeah, pixel precise. Well, imagine that these two lines are at the same place. They can be arbitrarily close, which is then not really a minimum or a maximum, right? I mean, it's just a horizontal thing. So might as well ignore that possibility. So I think we always have either a minimum and a maximum, or we don't. I mean, I said we don't. Like so. So here we do and here we don't. Cute. Clamp, check. I think so this part was already done. It's just the cubic, and then we calculate the maximum and the minimum, which is depending on the square of c. So c must be positive, or we don't have a minimum and a maximum, or they're the same. If c is 0, but I'm going to assume that then we don't have anything. Pretend, rather. Wait, it's more complicated. There's also a square root of d here. I can't read. It says square, not square root. Okay, so it's what I said was nonsense. It's just all about d. Good. So we have to begin with calculating this. And then we can look at the sine of d, and then we're already halfway, I suppose. Yes. Yes. That has to be done in this function. Let me make some aliases. Yeah, I don't know. Shall I make aliases? What do you think? That's the reason. If you describe a reference as a wrapped up pointer, then sometimes people complain because it's in the standard it's described as an alias, meaning that it's completely free for the compiler to ignore the fact that A exists. That this A does not need to take any space on the stack or have a memory associated with it. And that's my hope if I if I would set this equal to my cubic at 0. I might as well, you know, use this everywhere, but then these lines get longer because there's a cubic here and there and there. Well, I think that even without optimization, the compiler is already free to say, yeah, well, you don't use this at all anymore. Might as well that there? I don't know. Anyway, in the end, it should not be slower. So let me add some aliases. I think this should work. We are inside approximation. Approximation has a cubic, which is a cubic polynomial, which has this operator here, which returns a double reference actually. I should be calling this one. I can. Oh, that would be temporary. So maybe you should make a copy to begin with. Now I'm doing premature optimization again. Just ignore this. This thing is private. Yeah, I'll just have to use this. And really, it shouldn't matter if my approximation is const or not, even though it will use one or the other. The assembly code really should be the same in all cases. Now this should be const actually, so I could make it const. In that case, it is returning a reference. Sorry, it's returning a double. And then to store a const reference to a temporary, that is allowed. But God, I have no idea what assembly code will be. Well, after optimization, it will be the same as what, no matter what I do. But using a const reference for something that returns a double is kind of silly. So I think the compiler will be smart enough to optimize everything in the most optimum way, even if I do this. Okay. So at this point I can do if d is less than 0, then we can't take the square root, which means that we don't have a minimum or a maximum, which means that we have to return. I can't even return anything in that case. I'll just return 0, I guess. I have to return something. Let me set these things to the correct value. Output H direction, there is no extreme, that would be undecided. So we have to reset it to horizontal direction undecided. And there is no extreme also here, unknown, apparently. Well, one of them should be okay, but I'll set both. Maybe I should leave one of them alone, actually. Yeah, I think I'm gonna leave H direction alone, which means that I never set it to undecided. Yeah, I don't know. Can I, do I have a default constructor? Because it's definitely not 0. If you have a default constructor, I might as well use that. You do. Okay, well, even really uninitialized. Great, exactly what I want. Well, but if D is not, well, actually less than equal. Okay, we dealt with that. Then I suppose it kind of depends on if I request something specifically or not. So let's say, which shall I do first? Specific request or specifically not request? This is not really an specific request, right? It's more like can't find a word. No, can't find a word. It's a limitation. So I could figure it out as if this was the case, and then if one of these is set, then okay, I have to throw it away anyway. I think this is more important. Actually looking for a minimum or a maximum. Then I know what to do. Then I know what to look for. And then, yeah, that's the first thing we should look at. If it is set. Let's say I am looking for a maximum, then I can just calculate the maximum. And if I look for a minimum, I can just calculate the minimum. What if I do not look for any of them, then I think I have to calculate both, because for any extreme, the prevalence will depend on the value of h direction. If h direction is left, then the extreme nearest to. So I need to have the actual values of them. Yeah, it's nearest. So in this case I have to calculate both, and in this case I just have to calculate one of them. Okay, let's first do up and then change the code later so I don't get duplication of that for the unknown. That's almost, I might as well calculate both periods, because it's the square root has to be calculated anyway, which is most of the work. The division, I could do 1 minus division and then a multiplication for both. Or is division equally fast as a multiplication these days? I wouldn't know. So yeah, this is kind of bullshit what I'm doing, right? So just calculate both, and then it's maybe even faster than doing a branch, doing an if. I can't help myself. Probably if I just repeat this, and then the compiler will still only calculate it once. But I'm paranoid. So if extreme equals up, then I want the maximum. And then so if each fraction is undecided, and then we just found it. I think actually I have to make a decision on if I want a minimum or a maximum. Maybe I should do this one first, and then just set the v direction, and then the rest doesn't have to take into account anymore that this has been unknown. Doesn't fit on my screen. I mean, it's not undecided, but it could be in between. Still a possible value. Let's see. Now I should be able to figure out again this. Well, not really. It's not required, but I prefer adding it. Let's see, I have let's say h direction is right. That means that the value is 1, so this is 1. And then we have the exact same thing, both minimum and maximum, relative to reference. I subtract reference. That means that I subtract WL. So we are talking about this one. I said it was right. The extreme nearest to, but right of SL. That's WL. So if it is on the right of SL, that means that it is larger than SL, so this is positive. So I need the smallest value of these two, but it must be positive. So if both are negative, then we don't have a solution. Is this correct? So I need to do this again, right? That means I want to use the maximum. Yeah. Right, so after this extreme is set to either up or down, which means I dealt with this part. Looking for an extreme anywhere. So kind of have to do this check again then. If all I do is set the value of extreme. Yeah, but well. Can I set this now? Should I first do restriction? Maybe I can set it maybe and then check it. No, I cannot set it first, of course. I'm gonna override that. So if I set it to left, then the requested extreme is left of the leftmost value. While if it was left, then it was left of the right value. Okay, so I first have to check this. These two could still make it fail. Let's copy that. And then if I handled that, then I think I handled everything of the upper part. Then I have an extreme value, and I know that there is an enter. So then I can just fill in the results. I'm going to disallow equals. I think. Stupid floating points. It's all a bit fuzzy, isn't it? So this is a reject, and I have to set it again. All those rejects. I'm sitting in the dark. 2 minutes. Yep. Okay. No, let's combine it then with another. Vertical direction. What am I doing? Horizontal direction right. And result is less than or equal WL. Yep. So this was already done. Huh? I return unknown when there is no solution, and I did already set this. So that is done. So I only have to set this and then can return the result. I think that should be it. Ish, yes. Find extreme does not match any declaration. Do it. Calling a protected constructor. Snore. Yeah. I'm going to make it public. Acquired by Sample and others. What is capital Sample? Oh, it's a constructor Sample. Yeah. So now we have a result. Apparently there is a minimum in between the two. That is a minimum in between the two samples at 12.7592. Well, I wouldn't know. I guess we better add a lot of stuff to the test suite to test this. No, 12 is definitely in between, and oh. Yeah. So tough to verify unless I would draw it. Yeah, so now I wrote code that can draw graphs, but it's still not something that you quickly do. It's still a lot of work. Well, maybe you can do it in 5 minutes, 10 tops, but by just copying what I already have, lots of code duplication. It would be nice, however, if I had support code that would just open the window and do the whole thing, everything for me, without having to write half an application for it. In this case, yeah, I could, off the cubic, of the approximation, I could create some kind of function. So maybe some kind of debug function that I can just pass a lambda and then say, well, dude, open a window and show it to me. But yeah, then I only have that cubic, right? I don't have. Well, I could probably eyeball that it is correct. In that case, without drawing vertical lines through the vertices and all. Yeah, all I need really is this. I could copy these lines to another program which already almost does it, and then connect that stuff more or less. So this is So still would have to set this range correctly as well. It's kind of annoying. Man, and then I start thinking about it and I can't type it all anymore. I should just get up and turn on the light. But I should also go to bed. So I have something like, if I get up to turn on the light, I should go to bed. So I cannot turn on the light. It's complicated. Delta W is a difference. W2 is the largest one. Let's set W min to the smaller one. That is W1. Where's my W? Okay, I can't find any key anymore now. W1 minus, let's say 0.2 times dW. Constant W max is W2. W2 plus 0.2 times dW. Then the X range is that. And you have to do something equally for the auto range. Yeah, I'm not going to finish it. I'm just going to bed. Climb check. I think I put them on the right values now. So this is 1045 and 1350. What? 1350. Hmm. Oh, wait a minute. That was correct. Yeah, this is correct actually. What is not correct is where they put it. But that is this. How can that not be correct? Oh, yeah. Okay, I'll look that. That's stupid. Yeah, I just should use S. Can't use W1 and stuff. Well, I could, but... bitter. And then I still have to set the slopes correctly, and then we have our graph. How fast can I do that? So those are the phi. That's in radians relative to the positive x-axis, and what I have is a derivative. Uh-oh. Let's see, the derivative is basically the tangent. And it should point to that way anyway, so I just need to convert a tangent to an angle. And then from the angle I make a direction again. And direction takes an angle or 2 points. S angle, that's the inverse. I think I just have to call A10 without a 2. Standard A10. That would give me the angle, no? Oh. 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 Well, prints it out. 1.2 and 1.3. So looks under the dot on the money. What is it? Yep, 1.2 and 1.3. And thus, I can finally go to bed, because now if I run the test suit again, we see that it's at 12.7592. I don't believe it. We have a minimum in between at 12.7592. Oh, we do, actually. That is here. Yeah. That is therefore correct. Yep, cool. Yeah, okay, tomorrow more. Good night. What am I doing? Why am I not going to bed? Okay, just one game, okay? Just one quick game. Pre-move it? Nah. Could have. Yeah. Understandable. Maybe not the best. Is that possible? Probably not. Well, actually, it is possible. Take 0, take back it, and it's defended twice. I could not take here, I think, because then he takes here, I take a queen, he takes a queen. Nah. This knight is so badly placed. It's unbelievable. Really unbelievable. But yeah, I wanted that this 4 moves to go there. I don't want to do that. I lost my black bishop though. Maybe I should do it. If I move it now, I can push it. If I block it, it just goes there. Okay, I'm doing that anyway. Let's do that anyway, and then defend it like this, and then if the knight comes here, I did take it. Is that not a good plan? Okay, maybe. Maybe play this pawn too. Make this bishop really bad. That would be preferable after he castled though. And then I can't do it anymore. There's a check here. There's a nasty check. Yes, it is a nasty check. Damn it. Castle, my friends. Then I know what to do. Then I will know what to do. He's really not wanting the castle, but also not understanding why I played this pawn, I guess. Why does he want to go there? Okay, I'm gonna castle short. Definitely don't want to castle long anymore. I think I'm kind of threatening to take the bishop now, right? So if you take back with the queen, I can just take this pawn. And if he takes with the pawn, then I take this pawn. Maybe I should even have taken it instead of moving my queen. Because I think either way, taking with the pawn is not that fantastic. Hello, Anub. I was going to bed, which means that I give in to... If I push the c pawn right now, he just takes it and I lose it. And his weak pawn is gone. Well, I don't want to give away pawns. I want to play on this weakness. I think my knight should go there. Or this knight maybe. But then how do we get there? It's also 4 moves. Well, more even. Nah. What the F is this, man? Suddenly he starts thinking 2 minutes. Yeah, there he is. Yeah, I like that, of course. Wow. Why is he doing that? Yeah, let's do a few moves with the knight. Oops, now you can play this. Ouch. Shit. I'm a complete idiot, as usual. That costs me equality. No, might as well resign. Anoop, was what you was coding? Yeah, it's a very big project, so you can't even explain it. What I did. There's a tiny piece of a tiny piece of the larger piece. Plus, I should be going to bed, so. Okay, how do I lose this in a nice way? I'm -2. I've lost 2 pawns. Devastatingly bad. I want to have my knight there, so maybe I should just try that. But if I go here, there, that doesn't work. Totally does not work. Let's start a crazy. Oh, he's gonna take this one. You gotta be really. Okay, let's defend my bishop, and then start my attack. The crazy attack. Maybe I'll win on time. Who knows? What a lame move. What an incredibly lame move is this. He's going to lose on time, I feel it. Yeah, like that. Oh boy. Oh boy. Oh shit, the queen can go here. Well, there, for that matter. That is not good. Oh, now, oh my god. Ah, damn it. Shit. And he takes a check too. Okay, I'll give him the benefit of mating me. He's so careful to non-stop give check. That's too scared to not give check. It seems. Even here. What do you think he's going to do? No, I'm running out of time. I hate this guy. Every move he gave check. Scared for the stalemate, which it didn't have. So yeah, why? And then get the extra queen, which was not necessary at all either. Takes the fun out of that I didn't give up. Okay, I'm gonna go to bed. Good night.